Okay, so here we have a question. Give us this pretty complex function, and they want us to take the derivative. So let's bring it on down. So f of x is minus 4x to the fourth root x plus 7 over x squared root x. Okay, so now we have the power rule, right? Which says if you have some kind of function, y is x to the n. You can take the derivative, the power comes down, you subtract 1 from the power. That's called the power rule. That's great and all, but this is only when x is in the top and not also, I should say also not in a root. It's got to be in the top and it's got to not be in a root. So now, because you might look, well, I'll just do it on. You might think, and this would be wrong, to just say I'm just going to do that one. So this, minus 16, then subtract 1 from the power, 30. Then I'll do the root. No, you can't. You can't do that kind of stuff. You can't do that. It's not true. The power rule only works um, when the x is in the top. It's not in a root, and yeah. So yeah, in fact. Let me give some. I should probably lay out all those things. So this is the power rule, but it's only, or it's not when x is in the denominator. You can't do it when x is in the denominator. X is in a root or x's are multiplied. It's only okay. It's okay when x in the top, x added or subtracted, but not multiplied. Not multiplied by other x's. Not multiplied by other x's. So, all right, here we go. So right here, like this and this. See how those are times, huh? You can't have two x's multiplied. It's okay to have a number like minus 4 times x to the fourth. That's fine. It's fine to have a number multiplying x, but not multiplied by other x's. They can be added, subtracted, but not multiplied. So okay, so what? So you've got to the first step here is the rewrite. We're not even ready to take the derivative yet. First thing we got to do is, so how do you rewrite? What am I talking about? Well, what is the root of x? X to the half power. So you got to do that first. Now what do you do with these guys? Same kind of thing. You've got to say this is x squared times x to the half power, right? So both those roots. Root of x is x to the half power, right? Let me just write that up here. Root of x is x half power. You just got to know that, Cole. It's going to come up a lot this semester. Just got to know it. All right, so let's keep rewriting. Why aren't we ready to take it? Well, these are two x's multiplied, and these are x's in the denominator. Not in the denominator, not multiplied. We got rid of the stuff in the roots, but we got more work to do. So we're not even ready to do the power rule until we get that cleaned up. So what do we do here? How do you handle x to the fourth times x to the half? What's the rule there? Well, the rule is you add the powers. Do you realize that? Do you remember that rule? Why? Well, think about x squared times x cubed. What does that equal? X to the fifth. Why? Because what is x squared? Two x's. What is x cubed? Three x's. How many x's you got? Five. So you add the powers, right? So I got to add these. Now, how do you add four and a half? Well, you got to get a common denominator. So that's x to the 4 plus a half. And so to add those up, um, same thing here. Here, let me take it slowly. Plus 7 over, same thing here. We're going to go x to the 2 plus a half, right? Because these powers are going to add. Okay, so now how do you add those? Well, you put this 4 over 1, and then you multiply top and bottom by 2. Same thing here. Put the 2 over 1, top and bottom by 2. Why? Because you can only add fractions when you've made their bottoms the same. So you got to know all these rules. These are the things that give people trouble in calculus. It's all these little fraction algebra kind of rules. You got to know them. So this becomes what? 8 over 2 plus 1 over 2. Do you see that? And this becomes 4 over 2. Sorry, I'm getting scribbly there. See what's happening there. It's getting a little ugly, isn't it? So what do we do there? What just happened? Let's see what's going on. So I'm trying to add 4.5. To do that, you got to put that 4 over 1, still 4, multiply top and bottom by 2. So that becomes, this right here becomes 8 halves. And this right here becomes 4 halves, right? 4 halves is a fancy 2. That's still 2 plus a half. And 8 halves is a fancy 4 plus a half, right? But now we can add them up. Minus 4x to the 9 halves. Do you see that? 8 halves and 1 half. And this is going to be 7 over x to the 5 halves. 4 half and 1 half, 8 halves and 1 half. Right? Okay, now are we ready to take the derivative? Not quite. This is still in the denominator. No x is in the denominator. We're almost ready. It's all rewrite. So this part's good to go. Plus 7, and what's going to move that up? Minus 5 halves. See what we got there? Now, minus 5 halves, that's the same as moving it down below. Now we're ready. Finally, after all that, now we're ready to take the derivative, do the power rule. Do you see what we've done? We've done all the hard work is up front. We had to, well, let's keep going. Let's take the root now. So now f prime. Now is the actual, see how we change from f to f prime? Okay, what do we do? This comes and multiplies here. So minus 4 times 9 halves, and then you what? Subtract 1 from the power. How do you do that? Well, that's 2 halves. 1 over 1, multiply top and bottom by 2. That's 2 halves. That's a fancy 1, right? Plus 7, and then this is going to come down. Multiply negative 5 halves and subtract 1 from the power. Minus 5 halves minus 2 halves. That's a fancy 1, right? 1 over 1, multiply top and bottom by 2. It's a fancy 2 halves. Like that one's a fancy 2 halves. It's a two, I should say 2 over 2 is a fancy way of saying 1, right? Then it's common denominators. A lot of this common denominators. So I know fractions are not people's favorites, but you've got to do this. If you're going to make it through calculus. Okay, what do you do with that? Right here with this 4 multiplying the 9 halves. All these rules. Put it over 1, right? Multiply tops. So that'd be minus 36 halves. X. These subtract 7 halves. Minus, now see up here, 7 over 1. Remember when a whole number is multiplying fraction, multiply the top and bottom of 7, and it's going to be negative, right? Because positive times negative is going to be negative. 5 times 7, 35 on the bottom. 1 times 2. X to the, what do we do with these powers? Subtract them minus 7 halves. 1 is 5 halves and 2 more is minus 7 halves. One more step and we have wrapped it up. I can just clean this up. 36 divided by 2 is 18. And I'll just leave 35 over 2. You can make it a decimal if you prefer it. It doesn't matter. Did we get it? I'm hoping that's it. Minus 18x to 7 halves. Minus 30. They put the x to 7 halves on the bottom. We left it negative on the top. It's the same either way. Either way, it's good. And so let me recap what happened then. That was a lot of fancy algebra. This is why people have trouble in calculus. You got to get these rules down. You got to put the time in to learn these rules. What happened here? So again, you cannot do the power rule, the derivative, when you have x's in the denominator or in a root or multiplied together. No. It's only okay to do the power rule when x's are in the top and they're added, subtracted, not multiplied by other x's. Okay. And not in a root. So we started right here and here, and we said, okay, first off, the root of x, we always make that x to the half. Root of x, x to the half. That's just a rule you need to know. Root of x to the half power. Then we got to add these powers. This is where people get in trouble. Got to add 4 plus a half. How do you add 4 and a half? You put the 4 over 1, and then you multiply top and bottom by 2, so it becomes 8 halves. 8 halves is a fancy 4. You can add those up. 9 halves, same thing over here. X2 and 1 half, so you can add 2 and a half. Put this over 1, multiply top and bottom by 2, becomes 4 halves and 1 half. 4 halves is a fancy 2, isn't it? So you can add those up. That's 5 halves down there. This is 9 halves up there. Only thing left to do is move this now up to the numerator. It's minus 5 halves. Now we're ready. Now we're ready to take the derivative because we have the x's in the top only, no roots, no x's multiplied by each other. They're just added. That's fine. Now do the power rule, which was what? Power comes down to the front and multiplies, and then you subtract 1. But how do you take 9 halves and subtract 1? You got to make it 1 over 1, multiply top and bottom by 2. It's 2 over 2. That's a fancy 1. You can subtract 9 halves minus 2 halves is 7 halves. Over here, same thing. Power comes down to the front, minus 5 halves, multiplying the 7, and subtract 1 from the power again. That's 2 over 2 minus 7 halves. And then just simplify this. And so there. Yeah.